Friends, welcome to my channel. Dhanesh here.
Let us discuss linear algebra, scalars, vectors, matrices, and tensors. See, a tensor is an array of data which is expanded in any number of dimensions. The number of dimension is called rank of a tensor. There are different types of tensors. Rank 0 tensor, a tensor that has zero dimension or no dimension, we call it as a rank 0 tensor. Rank 1 tensor, a tensor that is expanded in only one dimension, that we call it as a rank 1 tensor. A rank 2 tensor means a tensor that is of two-dimensional tensor, we call it as rank 2 tensor. A rank 3 tensor means a three-dimensional tensor that is like matrices placed one after another. You can see it in the figure. Now let's discuss about scalars. Scalars, we call it as scalar or rank 0 tensor. A scalar is a zero rank tensor. In physics, various quantities are represented as scalar, such as distance, temperature, speed, energy. These are all scalars in physics. Next is vector. A vector, as discussed, a rank 1 tensor is called a vector. Physical quantities such as velocity, displacement, acceleration, electric field, magnetic field are vectors. Next, I will discuss about the difference between scalar and vector. A quantity that does not require additional information such as direction is represented as a scalar, whereas a quantity that needs direction to the specified uh, direction, a quantity that needs direction in direction and magnitude is represented as a vector. I told electric field is an example. A vector is denoted with a bold letter or an arrow above the letter. Fine. Matrix. Next, we will talk about matrix. A matrix is a rank 2 tensor. A tensor with rank greater than 2 is called a tensor. There is no specific name for tensors with rank more than 2. See, matrices we can express as product of vectors. That's another point. Here I have shown you can completely understand what exactly is a scalar, vector, matrix, and tensor. This is a pictorial representation that gives more clarity on scalars, vectors, matrix, and tensor. Next, I'm going to discuss about Einstein's, metric tensor. There is a correction in the spelling here. This is metric. Einstein's a metric tensor, M-E-T-R-I-C. M-E-T-R-I-C. Sorry for that. Einstein's metric tensor is a central object in general relativity that describes the local geometry of space-time. The metric tensor is commonly written as a 4 by 4 matrix. The matrix is symmetric and thus has 10 independent components. So that's all about scalars, vectors, matrix, and tensors.
Thanks for watching. Please like, share and subscribe. Thanks a lot.